welcome to our next video on transformations in our Big Ideas book, lesson 2.4, page 62. And we are going to continue transforming figures. Today we are going to apply what we learned to draw a rotation in a coordinate plane and, of course, list the new image location. Our essential question: what happens to a figure when you turn it? And does the figure change after moving it? So you should have taken some notes from the top of page 62, and there's a couple key terms in here. One, rotation. What is a rotation? In elementary, you learn that as a turn. Okay? So what we do? We spent one lesson where we translated the figure. That means we slid it. And then we spent the next lesson where we reflected the figure, and that was taking its flip. And then this lesson, we are going to rotate the figure. In other words, we are going to turn that figure. And all figures are turned or rotated about a center of rotation. So important. When we rotate it, there is a center of rotation. And the number of degrees that the figure rotates, well, that will be called the angle of rotation, and we'll talk about that in just a moment. And of course, just like with the other two transformations that we have done, if we rotate the figure, the original and its image are congruent. Okay? So they are congruent to each other after we rotate it. So you have this nice picture, and in this picture you can see we have the original figure, which would be the red one. This would be the original figure. And then it is turned. And in this particular case, it is turned clockwise. And you can see it is rotated about the center of rotation, that right here. And that the number of degrees that it rotated is called the angle of rotation. In this particular case, it was rotated 90 degrees, because you can see a 90-degree angle there. There's one other thing I'd like to talk about that it doesn't talk about in the book, and that is that all points on the image are the same distance from the center of rotation as the original. And of course, all points are rotated at same angle of rotation. In other words, take a quick look right here. Let me make sure I have my black going. If I take this point right here on the original red figure, and I take its corresponding point on the image, if I draw it to the center of rotation then over, notice these two lines will be the same distance from the center of rotation, and there is a 90-degree angle there. Just the same as there would be, I'm going to erase this real quick, just the same as there would be if I took this other point and this point right here, and I drew it to the center of rotation. That line, that distance, is the same as the distance to its image, corresponding image point, and there would be another 90-degree rotation. So every corresponding point rotates the same angle of rotation, and those points better end up the same distance from that angle of rotation. Alrighty, so let's just take a look. The first thing we're going to do, as we've done before, is we're going to identify if a figure has been rotated. And one of the things that you can do is you can actually take your pencil and stick it on the center of rotation if you have a piece of paper with these figures on it, like you have with your insert, and you can actually rotate. And you can rotate and see, does the red and the blue image, do they eventually take each other's place? In other words, could I turn this in either direction to get the original figure, or to match up rather? And the answer to this one is actually yes, this is a rotation. Because if I were to turn the paper, the red would go right on top of the blue. And we are going to show you some of that in class. Okay, let's try this next one. And of course, on this one, you can see that no, we do not have a rotation from the red to the blue, because this looks more like a reflection. If I were to draw a line of reflection here, I can see that the corresponding points are the same distance from the center. So this one is not a rotation. It is a reflection, but that's not the question. The question is it a rotation? And the answer, no. This is not a rotation. Make sense? Well, ladies and gentlemen, I'm going to stick something here real quick because this first video is pretty short, and the second one would be a lot longer. So I'm going to shove some very important notes right here into your first video before we do our quick write on identifying a rotation. Because this is going to be helpful mathematically for us doing a rotation in our next video. So, ladies and gentlemen, first thing we need to do is say, hey, this is a coordinate grid. Now I want to talk about, we have how many quadrants? That's right there, 4. What are the coordinate signs, positive, negative, for those coordinates in the first quadrant? That's right, the first quadrant is positive, positive. So important to know that, write that in there. What about quadrant 2? Yeah, quadrant 2 is negative, positive. What about quadrant 3? Yep, negative, negative. And quadrant 4, positive, negative. Now, ladies and gentlemen, take a look. Take a look at what happens when I do opposite quadrants. So if I do quadrant 1 to quadrant 4, I go from positive, positive to negative, negative. They're opposite. If I go from quadrant 2 to quadrant 4, I go from negative, positive to positive, negative. Outstanding. So now let's talk about rotating. If I rotate in this general direction right here, this direction is called the clockwise direction. So important to know, if I'm turning something, I have to physically turn that paper in that direction. Okay? Or that's the direction that the figure is going to rotate. Okay? And if I go this direction, this is called counterclockwise. Trying to write that way. There you go. That's counterclockwise rotating if I go the opposite direction of a clock, right? Outstanding. So now there's 3 types of rotations that we have to know. The first one is a 180-degree rotation. If I rotate 180 degrees, there's a couple things that happen. 1, the coordinates. The coordinate numbers stay the same. Okay? So anytime I talk about coordinates, I'm only talking about their numbers. Now the signs of those coordinates are opposite. Just like we talked about when we went from opposite corner to opposite corner. Think about this. 180 degrees is opposite. We talk about that all the time because we are going to rotate. If we rotate 180 degrees, we go to opposite quadrants. Okay? Now, if I rotate 90 degrees in either direction, 90 degrees clockwise, 90 degrees counterclockwise, here's what happens. The coordinates switch. In other words, if I had a coordinate of 4, 3, and I rotated 90 degrees, I don't care if I go clockwise, I don't care if I go counterclockwise. If I'm at 4, 3, and I rotate 90 degrees, I now become 3, 4. Those coordinate numbers switch places. Now the signs on a 90-degree rotation, the signs are of the new quadrant. If I go 90 degrees, I'm going to end up in a new quadrant. Whether I go clockwise to the right or counterclockwise to the left, I'm going to be in a new quadrant. So the signs are going to be of the new quadrant. This is going to make sense when we actually do one. And lastly, ladies and gentlemen, we have to know what a 270-degree rotation is. If I rotate 270 degrees, now this is interesting. A 270 degrees is the same as a 90-degree rotation in the opposite direction. Okay? So if I rotate 270 degrees clockwise, it's exactly the same as if I went 90 degrees counterclockwise. I hope that makes sense. Ladies and gentlemen, we're going to talk about this again very briefly when we begin the second video. But right now we're going to take a break after we finish our first quick write. So I gave you a copy of this, and you have to decide, is the dashed figure a rotation of the solid figure? Yes or no? Take a quick break and join me for video number 2.